Okay, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah. We meet again on this lesson, still in the boost converter topic, but on the analysis on the inductor current of the boost converter circuit. So I have write down the equation that we have derived in the earlier lesson, which is the V out VDC, and then the change of IL during turn on and the change of IL during turn off. Okay, and I would like to draw the waveform of the voltage of the voltage across the inductor here, because this will be the main actually analysis parameters. Okay, so VL T, okay, because it is time dependent. So this is during switch on and during switch off. So during switch on, okay, the inductor voltage is equal to VDC, okay, while during turn off it is equal to the value of VDC minus V out. So this one will be always negative because this is boost converter, so V out will be always larger than the input. Okay, so this is the voltage waveform. Okay, and then let's look on the current inductor waveform. So the current inductor waveform based on the change of IL during turn on, so this one is a positive, so meaning that it will actually start from a minimum current, we call this I min. It will ramp up to some value current, so this one we call I max, same, okay, I max. So and then during turn off, okay, it will be a negative. Why negative? Because V out is always larger than VDC, so it will ramp down from maximum value to its minimum value. Okay, so that is the waveform of the inductor current. So it has a maximum and minimum, and same as a buck converter. So this difference between max and min is actually the change of IL. Okay, and I would like to mention again that IL is equal to delta IL on, and it is actually equal to delta IL off. So, okay, and then to actually calculate the IL is okay. So since the current of the inductor is minimum, is in the cyclic manner, minimum change to its maximum value. So meaning that it has some average, it has an average value here. Okay, so at the center, so we call this as a IL average. Okay, so meaning that to get I max, you can calculate by using IL average plus delta IL half. For I min, you can calculate IL average minus delta IL over 2. Okay. Okay, so you can use IL here. IL here, you can either use IL on or IL off. Depends on which one you prefer, because as you can see that IL is actually, the value is similar. Okay, okay, so right now, what is the value? What is the equation of delta? What is the equation of the IL average? Okay, to obtain the IL average equation, we cannot, if you recall back for the buck converter, the IL average is equal to I out. Okay, by right now, we cannot see the relationship between the inductor and I out. Okay, so we cannot say that IL average is equal to I out. Okay, so how to derive IL average? So the derivation is based on this equation. There is this relationship, which is P in is equal to P out. Okay, and P in is, you know, is actually P supply, sorry, should be VDC multiply with the I source. Okay, but right now, as you can see, I source here is similar to IL, so we can say that IS is IL. Okay, and since IS is a DC current, so IL here is the IL average, which is a constant DC. Okay, so based on that, they can write down the P in as a VDC multiplied with IL average is equal to P out, where P out is actually V out square over R. So finally, we can have your IL average is V out square over VDC R. Or in other words, if we expand this, it will become as VDC square over VDC 1 minus D square R. So we can actually write down because we cancel out. So we will have 1 minus D. So this is your IL average. Okay, now we want to analyze about the CCM. So what is the value of the inductor so that this boost converter will always conduct in under CCM, continuous current mode. Okay, CCM, continuous current mode. So it depends on the I minimum. So I minimum is must equal to set is equal to 0, and we know that I min is IL average, which is VDC over 1 minus D square R. Okay, minus I use VDC I on DT over L. Okay, then this must set equal to 0. So finally, after, so this one can be write down as sorry, so this one will become equal to this. So L minimum, you can calculate it by using 1 minus D D over frequency LF. Oh, sorry, this one should be 2. Okay, 2. So this one should be 2 R. Okay, so this is L minimum, and usually the L actual that you need to use should be 10 times larger than L to ensure that it is CCM. Okay, so I think that's all for the inductor analysis. So we meet on the next lesson on the ripple voltage.